We use integration by substitution when we have a product of two functions of x, and generally speaking you will be told what to substitute, so that will actually be your clue that you need to use substitution. You start by finding what du dx is, and then you rearrange that to find out what dx is in terms of du. So we're treating the du dx like a fraction. Then you need to replace all the x terms with equivalent u terms. Sometimes you don't need to change all the x terms, as sometimes they get cancelled out when you do the replacing of the dx. I'll show you an example of that later. Don't forget, you also need to change the limits from x to u as well, if you've got one that's got limits. And you need to integrate the easier u version. Then you can turn it back, if you weren't given limits, into the x version. So let's get started. Here's our first example. And we've been told to use the substitution u equals 4x minus 3. So the first thing we're going to do is differentiate that. So we've got du dx will equal 4. So remember, the purpose of this stage is to get dx on its own in terms of du. So rearranging that, we get dx equals du over 4. Okay, so now we need to turn the other parts into u. So the bracket part is straightforward, that's just going to be u cubed, but we also need 2x in terms of u. So let's take u equals 4x minus 3. So that means that u plus 3 would equal 4x. And therefore, to get our 2x, we're just going to divide through by 2. So 2x would be the same as u plus 3 over 2. Now remember, we also need to change those limits. So when x equals 1, u equals 4 minus 3, which equals 1. And when x equals 3, u equals 12 minus 3, which is 9. So now we're going to rewrite the whole integral using u instead. So we now have our limits 1 to 9. Our 2x was u plus 3 over 2. And then our brackets is going to become just u cubed, and du over 4 is going to replace our dx. So if we tidy that up a little bit more, we're going to have u to the 4 plus 3u cubed all over 8 du. So now let's integrate. So I'll bring the 8 out, so we've got 1/8 here. So we're going to have u to the 5 over 5 plus 3u to the 4 over 4. And we don't add the c, remember, if we're doing limits. So now what we need to do is evaluate. So we're going to have 1/8, and in the first part we're going to have 9 to the 5 over 5 plus 3 times 9 to the 4 over 4, and that will be minus 1 over 5 plus 3 over 4, substituting in the 1. Okay, and then I'm not going to go through the process, but you type all that into your calculator, you'll end up with 2091.2. Here's our second example. We're being told here to use u equals sin x. So start again by differentiating this to get du dx. and that will be cos x, and then we're trying to get dx on its own, so dx will be the same as du over cos x. Now notice we've already got a cos x over here, so this is an example of when we put in the dx replacement, we're going to get rid of that cos x, so we don't have to worry about changing cos x into something in terms of u. So rewriting our integral here, we're going to have 3 cos x times u to the power of 4, and then putting in our dx, we're going to have du over cos x. So as I said here, we can see that these are going to cancel out, and so our integral is just going to be 3u to the power of 4 du. So let's do that. So that's going to be 3u to the power of 5 over 5, and we do need a plus c this time, and then in this case our final step is to turn it back into the x version, so we'll have 3 sine to the power of 5 x all over 5 plus our c.